Truffle is a smart contract development tool. So a smart contract is an agreement between you and, let's say, the Ethereum network, that you give it some logic, like maybe, so today we're going to attempt to write a rock, paper, scissors game. I should keep the chat on screen, sorry. I'm going to keep the, William, I do not know where to learn about blockchain with zero experience because it took me months. There's the Truffle docs. I like the Solidity docs. They have, the pet shop tutorial is good, yeah. I like the Solidity docs description of smart contracts. I think that's probably a good start. If you're not familiar with code, I don't know, I mean, I'll try and explain things as I go. But like the example on screen here is the simple storage smart contract. So that's, if you want to use this contract terminology, you can think of it like an agreement. And who is in agreement? Well, it's you and the network, right? It's not you and a counterparty. Well, the counterparty is just the network. Yeah, I followed the recommendations of people that have resources like that. So this simple storage contract, well, what it says it does, and what the network guarantees that it does, is it stores some data, right? A uint, that's an unsigned integer, so it means everything 0 and up, no negatives. And this contract lets you set that integer and then get it later. So this is a very simple contract, right? There's this agreement between you and the network. The network will hold on to a value for you. You give it a new value, it'll hold on to that new value. That's not super interesting, but hopefully it kind of gives you a sense for what we're dealing with. Generally, though, I like these docs because they kind of take you through what it is. Right, and there's this blockchain basics section. I'd read this if you're really just getting started. Today, I'm going to try and focus more on like, what does Truffle do to make it, to help you reason about your smart contracts, right? You're telling this network that it better do whatever you want it to do until the end of time, right? Like the simple storage example, it's going to run, as long as if it's on Ethereum, it's going to run as long as Ethereum exists. So you better be correct. And so it's kind of hard, right? Like if you were all at the main stage Teams demo with the rock, paper, scissors, there's how do you prevent someone from seeing what happened before they make their move, right? Like maybe Josh cheated and looked at what Mike's move was before submitting his own move. You have to think about those sorts of things. And so testing is very important. Like having good tools makes this so much easier. And that's kind of what I want to show today, and take you through that and take you through what Truffle does to make that easier for you. So I was ambitious. Those of you that joined early, I was already saying this. I was thinking that we would be able to code rock, paper, scissors in a half-hour session. That is entirely unrealistic. But I got it started. So what did I do? Well, I guess you have to install Truffle first. And I'll put these notes online somewhere after this is done. I'm going to take notes as we go. I use iTerm2 on Mac, and I'm using tmux, which is the thing that gives me the different the panes, like window panes. You can think of this like VS Code. Like here's my source code. Here's my terminal. Here's a little notes section. Yeah, I'm stubborn. So this is what you're getting. So anyway, what have I done? Well, I installed Truffle. I did Truffle init, and then I installed OpenZeppelin's test helpers because they're really handy. Specifically, I'm going to be using them to test events. And then why this is Gnidin style? Well, I went to the Truffle config. Full screen so you can see it. So I'm in the Truffle config. So a Truffle project has, show you what it looks like. There's a contracts directory, a migrations directory, and a test directory. If I just give you a new project, I just went into a new directory. Oops. I do truffle init, and I'll show you what you get. You get contracts, migrations, test, and you get a config. So in this crash course example, I'm not still in a new project, so I've got some other stuff in here. But you can still see there's contracts and migrations and tests, right? So let's look at the truffle config. There's a bunch of stuff in here. The one thing that I'm interested in is I want to use the latest Solidity. I always want to use the latest Solidity because they have security fixes and they don't backport them. So on Truffle, the default is 0.5.16. It's set to that for backwards compatibility reasons, but since this is the crash course and getting started, just upgrade to the newest Solidity. And then the other thing that I did was when you get a new Truffle project, it gives you this, I'll go back and show you, it gives you this migrations.sol contract. And this is another backwards compatibility thing with Truffle. Truffle would store your, if you want to deploy a bunch of contracts, it would save a record on chain, hey, I deployed your first contract. And then it would save on chain again, hey, I deployed your second contract. And every one of those operations costs gas, right? Gas is network fees, right? You have an agreement with the network. What's the network's incentive for keeping that agreement? And what that incentive is that you're going to pay the network to do it. And you pay the network in gas. So when you deploy a contract, you pay gas. You pay the transaction fee to deploy that contract. So with this on-chain migrations business, that's like not only do you have to pay to deploy all of the contracts, you also have to pay to tell the blockchain that you deployed all the contracts. So that's no longer necessary. So I just delete it, right? RM contracts, migrations.sol, and I do RM migrations. One initial migration is gone. I don't want it. You probably don't either. But here we are. What have I done? I installed Truffle. I did a Truffle init. I installed the test helpers because we're going to use them. I switched to the latest Solidity, and I got rid of extra cruft. What next? Well, started this rock, paper, scissors contract. What does that have? Well, there are choices. You can either not make a choice. You could either choose to throw rock, you could choose to throw paper, or you could choose to throw scissors. So this is an enum. It's like a list of values. You can it's so that you can give them all a name, right? In the example earlier, they used uints, and that just kind of makes my blood curl. Even though it's way easier to use uints in Solidity. But anyway, so we have a choice, and then we have a play. So let's say there's a host and a challenger. So the host makes a choice, and the challenger makes a choice. Then we have a result, right? Based on those two choices, it's either a tie, either the host wins, or the challenger. Does everyone know how to play rock, paper, scissors? Maybe I should check that, right? Rock, paper, scissors, shoot. Anyway. So, because there's, you think so? I'll teach you later. So a game has a host and a challenger, and then it has some plays, right? Let me try and get this all. I'll move this down so you can kind of see things more closely together, right? So there's a play and there's a game, right? There's the host makes a play. Oh, no, I have this wrong. Yeah, sorry, I was doing this, right? So this is, that comment's outdated. So the reason I have, this is a list of plays, right? Because if you're playing rock, paper, scissors with someone, you're like, I want the top bunk. I'll rock, paper, scissors you for it. And then you keep throwing, both of you keep throwing rock, you keep having ties, so you keep playing until one of you wins. So that's what I'm doing here, right? There's a host, a challenger, and then you're going to keep making throws until one of you wins. And each play has a result. So this is maybe, I'm just trying to set up context. I have this result function. For any play, right, there's a host choice and a challenger choice, and it tells you whether it's a tie, whether the host wins, or whether the challenger wins. We don't have to get into this. Because what I really want to show you is, let's do some plumbing, right? Let's pretend we have this code that tells you who wins a rock, paper, scissors play. Now let's get this on chain. So what you have to do is, we got rid of that one initial migration for the on-chain stuff, but we do still need to deploy rock, paper, scissors. So Truffle will handle this for you, but you have to tell it what to do. You have to say, hey, Truffle, I want you to deploy rock, paper, scissors. And that's what it looks like. This is how you tell Truffle to do that. You open up your migration /1 deploy game, or whatever you want to call it. And then what you do here is you say, hey, I'm talking about this contract. I have a contract named rock, paper, scissors, right? We just looked at it. And I'm going to want to do something with it. So please give it to me. And so we get it. And then we say, hey, please deploy it. And so what happens here is, well, if I do, and I'll go into this. This Truffle Develop is a like this interactive development environment. It's like one click, or full screen. It just gets you started really easily. So it lets you do things like migrate. And I probably didn't clear out my data before, but let's see if this works. So what migrate's going to do is it's going to compile all your contracts. And then it's going to deploy rock, paper, scissors. So there you go. Truffle in the background is running a private blockchain, a blockchain with just one participant. So this isn't mainnet Ethereum. This is just private to you. This is so that you can write code, understand what you're writing, understand where it works, where it doesn't work, and get this like rapid iteration, this rapid feedback. And then when you're done, you can deploy it to mainnet. But for the time being, you can just use Truffle Develop and kind of get started. So you can also, if you just need to compile, you can just run compile separately. Right, well, we already compiled, so that's fine. Anyway, how are we doing so far? Am I going too fast? Am I all over the place? Cool. So how do I even know where I'm at? I have this contract. Oops. I started making this host function. I'm going to call it host game, actually, right? I'm looking for a challenger to play rock, paper, scissors. So I'm going to interact with this rock, paper, scissors contract, and I'm going to say, hey, I want to make a new game. And this is me. Whoever starts the game is going to be message.sender. This is like a special variable in Solidity. And so what we do is we just say, we need an ID for the game, right? We have this list of games. And then, whatever's at the end, or what isn't there yet. So we grab the ID, and then we make a new game by doing games of ID.host, and we say, hey, I'm the host. And then we return the ID. So we're going to need a join game, right? And that's going to need an ID. So that'll be a uint256 ID. And that's public, and it's not going to return anything. All it's going to do is it's going to say games.id challenger equals message.sender, right? So there, we have the hosting and the joining. And let's see if that compiles. Hold your horses, Justin Barca. Well, actually, in Solidity, yeah, we probably should have an existence check. So let's do that. But let's do it by writing a test for it. There we go. I'm going to get rid of the stuff that I was trying to do. So should not let you join a game that does not exist. So how do we do this? This is kind of test-driven development, right? It's the idea where you know what you want your software to do before your software does it. So what do we want it to do? Well, we have RPS. This is JavaScript code. And that's rock, paper, scissors got deployed. And then we want to look up in the Open Zeppelin test helpers how to make sure it reverts. Yeah, this is how you write code, people. Check that transactions revert. Wonderful. So we're gonna use that. Expect revert. So we're gonna say expect revert. Let's see how to use it. That looks pretty straightforward. So all you do is you have this await, expect, revert. You're going to do something, and then you're going to want some kind of message. So we're going to say await, expect, revert, rps.join game. Oh, right. So, yeah, thanks for keeping me in check. So a revert means something went wrong. It's like you broke the contract, right? You shouldn't be able to join a game that doesn't exist. So when you do that, and revert's a technical term, it means the transaction fails. So, and the transaction is a technical term, meaning some interaction. So you're making some interaction. The interaction is you're joining a game. The game doesn't exist, so that interaction should fail. So in Ethereum speak, that is you sent a transaction to the rock, paper, scissors contract specifying that you want to join a game. And that transaction reverted. Does the terminology make sense there? Wonderful. So we're going to join a game, say, join game 100. We'll say, it really should tell us unknown game. Let's see. Back here, I'll run test. Probably need to do that. Yeah, sometimes if Truffle doesn't think you need to recompile your contracts, you can just specify that. That is the same result. So what's the problem? Let's go back into our contract, rock, paper, scissors. Have this join game. And something went wrong. You want to see what went wrong? I mean, I don't even know what went wrong. So, Carlos, since you asked for it, let's get into the debugger. Let's do this again. And what we will do, we need to get the transaction hash for this to work. So in order to do that, I'm going to make this, I don't need these notes anymore. I'm just going to do Truffle Develop -- log. And this is going to tell me everything that's going on. When I run test, you can see what Truffle's doing under the hood. It's like saying, hey, what's the blockchain? Hey, what are my accounts? You can kind of look at this. And the latest one, right, in that test result, we saw this message, invalid opcode, that doesn't make any sense to us. But we have a transaction hash associated with it, right? Every interaction with the blockchain that you make, well, any operation that persists, that stays around, it gets a transaction hash. And this is a unique identifier, and we can use this unique identifier to dig in more closely. Let's do that. And we have the Truffle Debugger, which will let us do that. So you just say debug, and you give it the transaction hash. And here we go. We are debugging the rock, paper, scissors contract. So there's a number of commands. Mostly I use N or O or I. You can also use V. And I'll show you that in a second. So N just means step next, right? This is a command line debugger. There are options. If you use Truffle Teams, we just released the visual debugger. I haven't quite figured out how to set that up yet, so you're stuck with the command line with me. So here we are. We're joining a game, right? So you want to see what ID is? It's that 100 we passed in. Whose message does sender? It doesn't really matter, but it's this person. Now, let's see what else. Yeah, so the debugger is, it just replays the transaction. It goes and it looks up the transaction, and it finds all the information, and it maps it back to your source code. So it knows that, hey, we're right here, we're on line 44. Truffle Debugger figures out where you are, and it figures out what all the variables are. So it figures out like what ID is, and you can do V to get all of the variables. And you can see there's no games. Which makes sense, right? So let's step next a little bit. And if you don't have to hit N every time, you can just hit Enter, and it'll replay the previous command. And you can see that it's stepping. Well, it broke. Well, I tried to get games of 100. I tried to get the 100th game, but it didn't exist. So it seems like that's the problem. And I mean, that's kind of what we want, right? We want our test to fail, right? It did not let you join a game that does not exist, but the error was wrong. So let's fix the error. I have until 40 technically. I'll go 5 minutes over. The debugger, so Firefly is a static analysis tool, which means that, the sessions will be on YouTube. There's static analysis and there's dynamic analysis. Static analysis means that it just looks at your program and it figures out what it can figure out. And Firefly can figure out quite a bit. Dynamic analysis means I'm going to run your program and I'm going to tell you what happened. You understand the difference? So Truffle is, like all of what Truffle does is really in the camp of dynamic analysis, although of course we integrate where we can with static analysis tools. But both have their merits, right? You want unit tests because you want to see what happens when you run your code. But you also want static analysis because if you forget to assign to a variable, that's something that computers can check using static analysis. All the stuff that Firefly was showing, you want that too, right? You want all of it. So, all right, let's just get this test passing. And the way we do that is with the require statement. You definitely want it all and more. So we want to say that games.length must be greater than the ID, right? Because if we have ID 100, we better have at least 100. And because it's 0 index, but just trust me. That is right. And the error is supposed to be unknown game, right? Let's see if I did that right. You can get out of the debugger. I hit Control D here. Control D means end of file. It just gets me back to Truffle Develop. And then I can run test again. Hey, how about that? So there we go. You just do that repeatedly for your entire career, and then you're a software engineer. What is it? The Truffle Suite has a YouTube channel, but I'm not the person to tell you what the URL is. If Liz is still around, or maybe Aaron knows. Or I would ask, oh, hey, Brian, also. So I don't think, what's the schedule for this? We only go, Oh, right, Coco. So Truffle Test is built on top of Mocha Test. So Mocha is a widely used JavaScript testing framework. And Truffle just takes that existing work, and if you're used to Mocha, you're used to something like contract to describe, right? This is what Mocha looks like. What Truffle Test does is it gives you this contract thing, and what contract does, it does a describe, but it also sets up the blockchain for you. It makes sure that things reset afterwards. It makes sure that you have this clean room environment, and it gives you some other things, right? Well, I won't go into, maybe I'll go into one fancy feature. I'll take off that expect revert, and I'll show you one more thing, which is stack trace features. So stack traces are expensive on Ethereum because actually what we're doing with this stack trace is we're using our debugger to figure out where we left off. So that's going to happen when this explodes, or it's going to tell me that I don't know how to write code. Comma there. Try that again. So my point in mentioning this is because you asked what the difference between Mocha and Truffle is. Well, Truffle gives you things like this. It'll tell you not only where, so this was in test/game.js, line 14, but it also tells you the solidity, where in solidity it failed. All right. You can kind of get a sense that Truffle gives you these features to make sense of what is going wrong. And it does that through giving you this automated testing framework, this interactive debugger, these stack trace features, and Truffle has a lot of features. I encourage you to look at the documentation, but it's along that nature, right? Truffle wants to provide this high level experience to make it easier to reason about computers, and computers are logical machines and humans are not. So how do you bridge that gap? And that's what Truffle tries to do. Should probably respect the time on this session. Are there any other questions? Absolutely, William. Yeah, if you have questions later, feel free to. It's okay. Well, ping me in the Truffle community Slack. I love helping people get knowledgeable. It's just like I like making tools to reason about hard problems. I like helping other people reason about hard problems. So don't hesitate. I will stop this screen share. Yeah, thank you all for coming, everyone. Really appreciate it. Hope it was helpful. I will talk to you all later.